All right, so I'm going to start with question 8. So this is prep test 70, game 2. Okay, this one is an in and out game. Okay, so we have an in group and an out group. The in group is the employees that are going to be on the research team, and then the out group is the ones that will not be on the research team. The team has to include a minimum of 4 employees. Okay, so at least 4. So it could include more. What it means when we have a minimum of 4 in is that we have a maximum of 4 out. Okay, because we have 8 total. So our 8 total include M, O, P, S, T, W, Y, and Z. All right. The rules here are all conditional rules. Okay, so we will be creating contrapositives. Rule number 1 is that if M is on the team, then neither O nor P can be. So if M is in, then O and P are not, right? They're both out. So the contrapositive is that if O is in or P is in, then M is out. Rule 2, if S is on the team, then P and T must be. If P is not or T is not, then S is not. 3, if W is on the team, then M and Y must be. And the contrapositive is that if M is not on the team or Y is not on the team, then W is not on the team. Okay. All right. So question number 8. So this asks us for a possible selection of employees for the team. Scanning through, I see that each of the answer choices includes exactly 4 players, so we've hit the minimum, so that's not going to be a problem. We just need to apply these rules. So if M is on, then O and P cannot be. So A breaks that rule, so we can eliminate A. If S is on the team, then P and T must be. So C breaks that rule because we have S, but we don't have T. If we have S, we have to have both P and T. So C breaks that rule. Okay. And 3, if we have W, then we have to have M and Y. So W, we should have M and Y, so E is out. Right? Okay, and the options that are left are B and D. So let's look at B. Right, so for B, we have O, P, T, and Z. So I'm going to go through and see what rules would be triggered here. So O is in, therefore M should be out. Okay, that's good. M is out. Okay, rule 2 is not triggered because P is in and T is in, and S is out, so none of those things are actually triggered. Okay, and then W is not in, so this rule isn't triggered. M is out, so W should be out, but that's fine, and Y is out, so W should be out. So B has to be the correct answer. So let's see what's wrong with D. So for D, we have S, which triggers rule 2. So we should have P and T, but we just have T. So answer choice D breaks rule 2. So B is the correct answer. And I'm going to show the other portion, right? So not just the in group, but also the out group. So here that would include M, S, W, and Y. Right? So that's a complete acceptable solution. Within an and out game, for an acceptable solution, it's good to show both sides, both the in group and the out group. Okay, question 9. Which one of the following is a pair of employees who cannot be on a team together? Okay, so If one of them is in, then the other one's gonna have to be out. Okay, so can M and T be on a team together? So let's try. So if M is on a team, then O is out, P is out. If P is out, then S is out. I don't see any other triggers for that. Now if T is in, does that have any consequences? No, it doesn't. T being in is not a trigger, so there's no reason to think that these two cannot be on a team together. Okay, so that's perfectly fine. For B, can O and Y be on a team together? So O being in means M and W are out. Okay, so M is out, which then triggers W to be out. Okay, and Y being on a team doesn't trigger anything. Okay, so B is fine. C, P and Z being in. So P being in means M's out. If M's out, then W is out. Sorry, not Y, W. And Z being in doesn't trigger anything. Z is wild here. There are no rules about Z. So that's not going to cause problems. D, if S is in, then P and T are both in. Okay, if P is in, then M is out. And if M is out, then W is out. The other player here is W. So if S is in, then W actually has to be out. So that means that S and W cannot be on a team together, which means D is the correct answer. Okay. I'll do E just for good measure. So for E, we have W is in. Now if W is in, that means M is in and Y is in. So W and Y can definitely be on a team together. Okay, so here we have S and W, which can't be on a team together, but in all the other ones, we didn't run into any conflict, right? So D is the correct answer here. That's the one that's impossible. Okay, let's get some more paper. All right, question 10. If Y is not on the team, then any of the following could be on the team except. So if Y isn't on the team, then what do I know? Well, I know W can't be on the team. All right, and let's see, what else do we have going on? So could we have Z on the team? Can't think of any reason why not. Okay, so I'm going through the answer choices now. So what I've done here is I've looked at the question specific condition, which is that Y can't be on the team. I've figured out what I can deduce based on that, right? So seeing what that triggers, and it triggers that W can't be in. Okay, so that's all I know so far. I also know that I have a minimum of 4 in, always, and a max of 4 out. So those are the important things to know at this point. And then I can go into the answer choices, and the goal here is to test to see whether the answer choice would be possible, right? Whether that player could be on the team. So if it's possible for that player to be on the team, then I have to eliminate that answer choice because we're looking for the exception. Okay, so if they could be on the team, then I have to eliminate the answer choice. So for A, could Z be on the team? No reason why it couldn't. Z is wild, it doesn't trigger anything, there are no rules about Z. So at this point, yeah, I can eliminate A. B, could T be on the team? Again, doesn't trigger anything for T to be on the team. Okay, that's not a trigger. C, could P be on the team? Now, if P is on the team, right, then M can't be. Okay, so that's the contrapositive of rule 1. If M isn't on the team, then that means W isn't, but we already know that W is not on the team. So that one's looking okay. Doesn't look like there's anything wrong there. We're going to have the exact same scenario if we replace P with O. So if O is on the team, that's going to lead to M not being on the team, which leads to W not being on the team, which is already something that's happening, so not a problem. We can also see from the original acceptable solution that we had that if Y isn't on the team, we can have O, P, T, and Z, right? So just based on our bank of acceptable solutions, if we took the time to write out that one for question 8, we can actually see that we can eliminate A, B, C, and D right away. So E has to be the correct answer, and the question is why, right? Why is it that M can't be on the team if Y is not? So if Y isn't on the team, then neither is W. If M is on the team, then O isn't and P isn't. And if P isn't on the team, then S isn't. And what we've done here is we've exceeded the maximum number of players out, right? So I'll go through that again. So we're told in the question specific condition that Y isn't on the team. We know from the contrapositive of Rule 3, that means that W is not on the team. All right, now we're trying to test to see if it's possible that M could be on the team in this scenario. If M is on the team, then O is out and P is out. O being out doesn't trigger anything, but P being out triggers the contrapositive of Rule 2, and that puts S out as well. Okay, and now we aren't going to have enough players to meet the minimum requirement that we have at least 4 employees on the team. Okay, so the only players left at this point are, what do we have left? We have T and we have Z, right? So M, T, and Z is not enough. That's not going to meet the minimum requirement. So that means that M can't be on the team if Y isn't. All right, next question. If P is not on the team, then what could be true? All right, so we have a question-specific condition, which is that P is not on the team, and we're being asked what's possible. So we start with the question-specific condition and follow that through as far as we can. So P not being on the team means that S is not on the team. Okay. Is there anything else? Yeah, it doesn't look like it. So we already have 2 players out. The maximum we can have is 4 out. So that's something to be cautious of. Is it possible that we also don't have M and we don't have O? Well, if we don't have M, then we don't have W as well. So that would be too many players out. So for answer choice A, if we also put M out and O out, then if M is out, W is out as well. So that's too many players out if P and S are out. So A is eliminated. B, neither M nor T is on the team. Again, M being out pushes W out, so that's not going to work. We can say the same thing for C. Okay. So if we don't have M and we don't have Z, then we're going to have too many players out. Okay, so we can eliminate A, B, and C. D, we don't have P, we don't have S. Now we're testing, is it possible that we eliminate O and T as well? If we eliminate O, that doesn't trigger anything. And if we eliminate T, we have to eliminate S, but we've already done that. So that doesn't mess with our maximum. We haven't hit the, or we haven't gone over the maximum. We have hit it. So that means that every other player would have to be in. So that would be M, Y, W, and Z. So that would be totally fine. So D could be true. It could be true that P is out, S is out, O is out, and T is out, and everybody else is in. And then the reason that E doesn't work is because Y being out is going to push W out as well. So that contrapositive for Rule 3 is really being tested heavily in this question. Okay, last question for game 2. Which one of the following is a pair of employees, at least one of whom must be on the team? All right, so this is kind of a tricky one, like a tricky question type, I would say. So first let's think through how we're going to test this. How are we going to answer it, right? And what are they asking us to test? So for this pair of employees, at least one of them must be on the team. So in any acceptable solution, we're going to have a minimum of one of these two employees. Okay, it's not possible for both of them to be out, is what they're saying. So we could look through our bank of acceptable solutions here if we've been keeping track. That's something that we could definitely do. We do have sort of a bank of acceptable solutions from question 9, right? We haven't totally completed them, but we do have some things that are looking like they could result in like a complete scenario. We also know from question 9 that there must be solutions where these pairs of employees could be together, right? Because the correct answer was one where those pairs could not be together. So there must be a way to complete these solutions where those employees could be together. So we can use those for our bank of acceptable solutions. So that allows us to eliminate A and to eliminate C. Okay, so O and S, it's possible for both of them to be out, and P and S, it's possible for both of them to be out. So that's how we eliminate answer choices for this one, is we see, is it possible for these two players to both be out? If it is, that means that we do not have to have at least one of them on the team. Okay, so if we can have 0 of them on the team, neither of them on the team, then we don't have to have at least one. All right. So O and W, can we put both of them out? Well, putting O and W out doesn't trigger anything, so that doesn't seem like too much of a problem. Okay, so what about T and Y? So if T and Y are out, then S would be out as well, and W would be out as well. So let's flesh this out. So we have T out, we have Y out, and then because T is out, S is also out, and because Y is out, W is also out. So everybody else has to be in. So that's M, O, P, and Z. Yeah, so I'm not, ooh, never mind. That's a problem, right? We can't put M, O, and P in. That's not going to work. Yeah, so there we have it. T and Y can't both be out. That's going to cause a problem for us. So that's going to result in us having to break Rule 1. Okay. And then Y and Z. So those guys can both be out. If we have Y out, we have W out, and if we have Z out, it doesn't trigger anything. We're going to need to put M out here, okay, so that we can put O and P in. Right, and then we'd have O, P, T, and who's left? S. Right, so we have S and P and T, and we have O. So yeah, that would work. But this here, this isn't going to work because if M is in, O is out, and P is out, and if O or P are in, then M would have to be out, so we can't have those guys together. All right, so hopefully that helps with game 2. Let me know if you have any questions.